Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from May June 2023, paper 1. In today's lesson, our main focus will be on waves, electricity, and radioactivity. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 25 says the diagram shows a string stretched between fixed points x and y. There is a stationary wave on the string. The solid curve shows the string at a position of maximum displacement at time t naught. The dash curve shows the other position of maximum displacement. The straight centered dashed line shows the mean position of the string. Point S on the string is directly above point P and point T on the string is directly below point Q. Which statement is correct? So first of all, let's try to understand a little bit about stationary wave. If you look at motion of this particle will go down. So this is one thing we need to understand. This particle will go down and all the particle here, this particle will also go down, particle here, this will also go down. And particle at this point, this particle will move up. And all the particle between these two nodes, they will be moving up. So they will be moving up. So all the particles will be moving up. So these are some points we need to understand about stationary waves. We can also look at this part. In this loop, mean between this node and this node, all the particles, they will be moving down. Mean particle here, this will be moving down. Particle here, this also will be moving down. So the particles in two consecutive loops, they move in opposite directions. Mean particles between these two nodes and particles between these two nodes, this is one loop. These particles, they will move in opposite direction to particles here and also they will move in opposite direction to particles here. So this is very important point you need to understand. Now if you look at given options, it is given to us a short time after t naught, point R on the string will be displaced. This point, this is the node actually. Particles at node, they just stay at node because they have zero displacement. So it means this option is incorrect. A short time after t naught, points S and T on the string move in opposite direction. This one is correct. So we have point S, this point is moving down, this particle is moving down, and particle at point T, this will be moving up. So they are moving in opposite direction. So it means option B is correct. The distance between P and Q is one wavelength. Mean distance between this point and this point is one wavelength. This is incorrect because this distance, this is equal to lambda by 2 because this is the distance between two consecutive antinodes. So this is also incorrect. The two moving points on the string that are equal distance from point R vibrate in phase. So we have point R here, so we can consider one point here and we can consider one point here. These points will be moving in opposite direction, not in same direction. So it means not in phase. So this option is also incorrect. So the answer for this question is B. So this question covers some important points about stationary waves. So these points are important, you need to understand. Question 26 says the variation with distance x of the intensity I along a stationary sound wave in air is shown in the figure. The speed of sound in air is 340 meters per second. We need to find out what is the frequency of the sound wave. So we have speed, we need to find the frequency. So if we have value of lambda, we can find out frequency. So for this one, it is given to you, this is a stationary wave. So it means this point has maximum intensity. So this point is antinode and this point is node. You can mark this point. So this one is antinode and this one is node. And the distance between two consecutive nodes are antinodes. This distance is equal to lambda by 2. Mean the distance between any two consecutive nodes or antinodes is equal to lambda by 2. So it means this distance is equal to lambda by 2. So we can write down here lambda by 2 in this case is equal to 10.0 centimeters. So lambda will be equal to 2 times 10.0 centimeters. It means this is equal to 20.0 centimeters. We need to find out frequency. Frequency will be equal to V divided by lambda, and value of V is given to us, that is equal to 340 meters per second. So lambda we also need to convert into meters. So simply we can write down this is equal to 0.20 meters. Now if we simplify this one, we will get 1700 hertz up to 2 SF. So this is our final answer. This is how you can figure out. Now let's try to visualize how the stationary wave will look like. If you draw the stationary wave, it should look like this. So you can see, you can also redraw. So in this case, you can see this point is node, this point is also node, and here we have antinode. So this point is antinode. So you can also draw the stationary wave here, so you can see the clear picture of stationary wave. Question 27 says an experiment is set up to demonstrate the diffraction of water waves in a ripple tank. The waves pass through a gap of width W and some diffraction of the waves is observed. The wavelength of the waves is now doubled. What is the new gap width needed to cause the same amount of diffraction as before? So for this one we need to understand, imagine that these are the waves, they are coming, and here we have a hole, means we have a slit here. If we increase this wavelength, if we increase lambda, diffraction will increase. So if we increase lambda, diffraction will increase, diffraction will increase. And if we make this hole smaller, if we make hole, we can say the width, if we decrease the width, diffraction will also increase, diffraction also will increase. And if we increase the width, if we increase this width, mean this gap, diffraction will decrease, diffraction will decrease. But for this question we have increased this lambda 2 times, so it means diffraction will increase by 2 times. To keep the same amount of diffraction, we also need to increase the width, so diffraction will decrease. So we also need to multiply this one by 2. So the new width has to be equal to 2W, because this will decrease the diffraction. It will bring diffraction to the same amount as before increasing the wavelength. So the answer for this question has to be C. So this is the important point, means if we increase wavelength, diffraction increases, and vice versa is also true. And if we decrease the width, diffraction increases, and if we increase the width, diffraction decreases. So the answer for this question has to be C. Question 28 says two coherent electromagnetic waves are traveling in a vacuum. The two waves meet at a point. At this point, the two waves have different intensities. Which statement about the waves is not correct? So these are coherent waves. So we need to understand the properties of coherent waves. Two waves are coherent if they have constant phase difference. So this is the first condition, constant phase difference, constant phase difference. And that is only possible if waves they have the same frequency. We can also say they should have same frequency, so we can write down same frequency. And also we need to understand these are two electromagnetic waves, so they are same type of waves, so they have the same speed in the same medium, so they have also the same speed. Same type of waves, they have the same speed in the same medium, so we can say same speed, so they also have the same speed, because speed of the wave, it depends on type of the wave and medium, so they have the same speed. Now if you look at given options, it is given to us constant phase difference, this is right. They have the same frequency, this is right. They travel at the same speed, yes. They have the same amplitude, this is incorrect, so this one is the answer. This is incorrect because intensity is directly proportional to amplitude square. If intensity is different, it means amplitude has to be different. So the answer for this question is B. Question 29 says a parallel beam of light of wavelength 600 nanometers is incident normally on a diffraction grating. The distance between the adjacent slits in the grating is 2.0 times 10 to minus 6 meters. A screen is placed parallel to the grating at a distance of 1.50 meters from the grating. Third order diffraction maxima are observed at the two ends of the screen as shown in the figure. We need to find out what is the distance between the two ends of the screen. Means we need to figure out this distance. So simply we can say this total distance, let me draw a dotted line here. Let's say this total distance, this is equal to capital H, and this distance, half of that, this distance we can label this one is H. So you can see this is just a triangle. So this one is the triangle. So first of all we will try to find out this angle. And this question is about diffraction grating. So for diffraction grating, d sine of theta, this is equal to n times lambda. So we can find out value of angle. D is given to us. So this one is the d we have value of lambda, and we also have value of n. So we can rearrange this one. We can write on theta in this case. This one has to be equal to sine inverse of n lambda by d. N lambda by d. Now we can plug in values. We have in this case n, that is 3, and lambda is given to us in nanometers, so we have to convert this one into meters, and we need to divide by d. D is the distance between two adjacent slits, and this distance is 2.0 times 10 to minus 6. Now if we solve this one, in this case we will get value of theta, means we will be able to find this angle, and this angle will be equal to 64.2 degrees. So now we have value of this angle. We can find out value of H because we have this side. This is equal to 1.50 meters, and value of angle we have found, that is equal to 64.2 degrees. We need to find out H. So simply we can write down tangent of theta, in this case will be equal to H divided by 1.50. So H in this case will be equal to 1.50 times tangent of angle. Tangent of this angle, that is 64.2 degrees. If we solve this one, we will get 3.1 meters. So this is value of small h, but we need to find out capital H, that is equal to 2 times of H. So it means 2 times 3.1, so we will get 6.2 up to 2 SF. So the answer for this question has to be D. A nice question. This is how you can approach diffraction grating problems. Question 30 says a metal wire is connected between the terminals of a cell, so there is a current in the wire. Which statement is correct? So first of all, we can simply imagine we have a cell and a wire is connected between the terminals of this cell. So we can imagine this red is the wire. So this is the wire. So in this case, electrons will flow from the negative terminal of the battery. So they will flow in this direction and they will come to the positive terminal of the battery because only electrons flow. So if you look at given options, we have negatively charged electrons in the wire move from the negative terminal to the positive terminal. So this statement is correct. Negatively charged nuclei, this is incorrect. Positively charged electrons, incorrect. Electrons are not positively charged. Positively charged nuclei, so these options are incorrect. So simply you need to understand only electrons flow. So the answer for this question has to be A. Question 31 says two resistors of resistance R and 2R are connected in parallel with a battery of electromotive force 12 volts and negligible internal resistance. The total power dissipated by the two resistors is 36 watts. We need to find out what is value of capital R. So in this case, these two resistors are connected in parallel, so we can find out R total. First of all, R total, this will be equal to R times 2R divided by the sum of these two. So this is the sum of these two. So here we will get 2R square, and this is divided by 3R, so we can cancel this R with this. So we left behind 2R divided by 3R. Simply we can say it is equal to 0.6R. So this is the total resistance. This is the total resistance, and we need to find out the value of R, but power is given to us. So simply we can say power, this will be equal to V square divided by R total. Value of V we have, that is equal to 12 square, and value of R we have, value of total resistance we have, that is equal to 0.6 R, and the power we have, that is equal to 36. So for this question, simply we need to find out value of R, so we can rewrite this 0.6 R. So we need to find out value of R. So if we rearrange this one, we can say 0.6 R, this will be equal to 12 square divided by 36. We need to find out R, so we can divide both sides. So this is 12 square divided by 36 multiplied by 1 over 0.6. So if we solve this one, our final answer will be equal to 6.0 ohms. So this is the final answer, and this is how you can approach this problem. Quite straightforward one. Question 32 says a wire has a length of 3.0 meters and is made of metal of resistivity 4.9 times 10 to minus 7 ohms meter. A potential difference of 12 volts is applied across the wire so that it has a current of 1.4 amps. What is the cross-sectional area of the wire? So first of all, we can draw the circuit. So here we have the power supply, and we have a wire, so we can imagine we have wire here. So this is the wire, so we can little bit draw in a better way. So we have the wire, so we can imagine this one is over wire. So we can make this one a bit thicker so you can see the difference. So this one is the wire. So it's very important in physics to sketch the diagram. Diagram is very important in physics. So you have to make this one your habit so you can improve yourself step by step. So this is the wire we have. The length of this wire is given, resistivity is given, current passing through this wire we have, and the PD across this wire also we have. If we connect voltmeter across this one, reading on this voltmeter will be equal to 12 volts, and current passing through this wire is 1.4 amps. So these informations are given to us. We can say this is 12 volts battery. We need to find out value of cross-sectional area of this. So simply first of all, we can find out value of resistance. So the resistance of this wire will be equal to V divided by I. Means this will be equal to 12 divided by 1.4. So this is value of resistance. We need to find out cross-sectional area, so we need to understand resistance is equal to rho L by A, and this is equal to 12 divided by 1.4. So we can rearrange this one. We can write down 12A. This one will be equal to 1.4 times rho times L, and if we divide this one by 12, so it means we can find out value of A. So this is our value of A. Now simply we need to plug in values and we can find out value of A. For this one, it is given to us that resistivity, this is equal to 4.9 times 10 to minus 7, and value of L we have, that is equal to 3.0 meters divided by 12. If we solve this one, our final answer should be equal to 1.7 times 10 to minus 7 meters square. So the answer for this question is B. Question says a cell of negligible internal resistance is connected in series with a thermistor, a fixed resistor, and an ammeter. The thermistor is placed in a beaker of water and the temperature of the water is slowly increased. A graph of current against the temperature T of the thermistor is plotted. which graph could show the variation of I with T. So first of all, we need to understand for the thermistor, if the temperature of the thermistor increase, resistance of thermistor decreases. If the temperature increase, resistance of thermistor decreases. It follows this curve. So for this question, it is given to us that temperature is increased. So if temperature of thermistor is increased, it means resistance of thermistor, this one will decrease. So resistance of thermistor will decrease. We can also sketch the circuit. So here we have cell and we have a thermistor. So it is given to us a thermistor is connected, and we have a fixed resistor that is connected here, and it is also given to us an ammeter is connected in series. So if you look at this given setup, as temperature is increasing, resistance of this thermistor, resistance will decrease. As resistance of thermistor decrease, it means the total resistance in the circuit decrease. If the total resistance of the circuit decrease and EMF of power supply remains constant, so it means current in the circuit will increase. So current passing through thermistor will also increase. So as temperature increase, current has to increase. So it means this is not possible. So this is our possible answer. This is not possible. This is telling you decreasing. This is also telling you is decreasing. Question 34 says a battery with internal resistance is connected to a parallel arrangement of two resistors and a switch S as shown in the figure. Initially switch S is open. What happens to the voltmeter and ammeter readings when switch S is closed? So first of all, we need to understand when we close this switch, what will happen to the resistance of this part. So the total resistance of this part, we can say R parallel, this resistance will go down. As this resistance go down, it means the total resistance of the circuit, this will also go down. So we can say R total of the circuit, this will also go down. If total resistance of the circuit decreases, it means current in the circuit, means I total, this one will increase. But for this question, we need to understand this voltmeter is telling us terminal PD, means VT, terminal PD. So the potential difference between this point and this point is the same as potential difference between these 2 points here. So if we connect our voltmeter here, reading on this voltmeter and reading on this voltmeter has to be the same. So this is terminal PD. So in this case, we can write down EMF. This one will be equal to the terminal PD plus V lost. So here we have V lost. So we can write down in this case terminal PD. This will be equal to EMF minus I times R. So now simply we need to understand this one is constant. This quantity is constant. This quantity is constant. So if I increase, how about this overall? This one has to decrease. It means terminal PD, this will decrease, but current will increase. So this one will decrease and total current in the circuit will increase. So ammeter reading will increase and this reading of voltmeter, this will decrease. So voltmeter reading decreases, ammeter reading increases. So the answer is A. So this is how you can figure out a typical question. You will see this one in many past papers. So this is the main concept. You need to understand how to use this equation. Question 35 says Kirchhoff's first law states that the sum of the currents entering a junction in a circuit is equal to the sum of the currents leaving the junction. The law is based on the conservation of a physical quantity. What is this physical quantity? Kirchhoff's first law simply tells us that sum of currents entering a junction, so we can say entering a junction, this is equal to sum of currents leaving the same junction. Leaving. We can also write down this one. This means the sum of the charge, or simply we can say the total charge entering the junction. So we can write down Q total entering the junction in a given time, let's say in time delta t. This one has to be equal to Q total leaving the same junction over delta T. So in this case we are talking about the same amount of time. So it means same amount of charge has to enter and same amount of charge has to leave the junction. So this law is simply based on conservation of charge. So we are simply talking about conservation of charge. So this is entering Q total, entering, so this has to be equal to Q total leaving. So this is based on conservation of charge. So we can say this is based on conservation of charge. Conservation. Question says two resistors have a combined resistance of 34 ohms when connected in series. The same resistors have a combined resistance of 7.4 ohms when connected in parallel. What is the resistance of one of the resistors? So we can sketch. First of all, it is given to us when two resistors, they are connected in series. The total resistance of these two resistors, this is equal to 34 ohms, means R1 plus R2, this is equal to 34 ohms. From here we can also write down that R1, this will be equal to 34 minus R2. So we can say this is equation 1. Later we will need this one. And for the second setup, we have two resistors. They are connected in parallel. So we can draw this one, mean two resistors are connected in parallel. So this is our R1, this is R2. Order doesn't matter. And the total resistance of these two is equal to 7.4. So we can write on this will be equal to the product of these two resistors divided by the sum of these two resistance. We can say this is our second equation. Now we can substitute R1 is equal to 34 minus R2 in second equation. So simply we can plug in here now. So we have 7.4, this is equal to 34 minus R2 times we have R2, and this is divided by 34 minus R2 plus R2. Now we just need to simplify. We have discussed the physics. This is the math part. We just need to simplify. So we can cancel this with this one. So we can cross multiply now. So we will have 7.4. This will be multiplied with 34. And here we will have 34 times R2 minus we will have R2 square. So we can multiply both sides. We can rearrange. First of all, we can write on this is minus R square. We have plus 34. So this is 34. So we have 34 R2 minus we will have 7.4 multiplied by 34. So here we have 34. This one has to be equal to 0. So we can multiply with minus sign. So we will have R square minus 34 R2, and we will have plus here 7.4 times 34, and this is equal to 0. We need to use the quadratic formula. So here we have A, that is equal to 1, we have B, that is equal to minus 34, and we have C, that is equal to 7.4 times 34. Now simply we can write on here R2 in this case will be equal to minus B plus minus B square minus 4 AC. This is just quadratic formula divided by 2A. So here is our R. Now we need to plug in values and we can find the value of R2. We have value of B, that is minus 34. We have plus minus B is minus 34. Square, we have minus 4. We have value of A, that is 1. We have value of C, that is 7.4 multiplied by 34, the root of this one, and this is divided by 2 times A. Now if we simplify this one, we will get two values of R. One value will be 23 and one value will be 11. If you look at given options, we don't have 11. So the answer for this question has to be C. So C is the answer. You can just simplify. You will come up with these two values. So in this case, this is not given. So we will choose this one. So this is value of R2. Question 37 says a potentiometer circuit is used to investigate the electromotive force of a cell X. The EMF of cell X is approximately 0.50 volts. The driver cell has negligible internal resistance. It's very important point. You need to check this driver cell, it has internal resistance or not. And EMF of driver cell is given, that is equal to 2.0 volts. The sliding contact is moved along the uniform resistance wire between ends Q and R to a point P where the reading on galvanometer is 0. What is an expression for the approximate length QP? Means we need to find out this length QP. Now for this question, it is given to us the reading on galvanometer is equal to 0 when the sliding contact is at this point. It means that the potential difference between Q and P, this is equal to the EMF of this cell, and EMF of this cell is 0.50. So we can write on here the reading on voltmeter will be 0.50 volts, and the potential difference between point Q and R, this is equal to the EMF of driver cell, because driver cell has no internal resistance. If driver cell has internal resistance, then we need to take the terminal potential difference across the terminals of the driver cell. Terminal potential difference then we need to take. So in this case, we have VQR, that is equal to 2.0 volts. And also we have in this case VQP, that is equal to 0.50 volts. We are talking about the same wire. For same wire, this is the point you need to understand. For same wire, current is the same. Means the same current is passing through this part of the wire and same current is passing through the remaining part of the wire, because current through galvanometer is equal to 0. So simply then we can say IQP, this is equal to IQR. So this is the main concept you need. So also, before I answer this question, you need to understand internal resistance of test cell. It doesn't matter. It has internal resistance or it has no internal resistance, because when current is 0, it means voltage lost across internal resistance, that will be equal to 0. So internal resistance of this cell doesn't matter. It has internal resistance or it has no internal resistance. But internal resistance of driver cell, it matters. Then if driver cell, it has internal resistance, so you have to take the terminal potential difference across driver cell. So that's the very important point. Or simply I can say what you need to take, V is this value of V. This has to be the PD across the wire. So that's the reason I have written here VQR. But in this case VQR, this is equal to EMF. So you have to take VQR. So IQP we can calculate potential difference, that is 0.50 across this part of the wire divided by the resistance. So resistance will be equal to rho L. So this L will be LQP divided by A. So here we will have 2.0 and this will be divided by the resistance. So the resistivity times length Q times R divided by A. So this is uniform wire, so it means cross-sectional area is the same. We are talking about the same wire, so resistivity also is the same, so resistivity will be cancelled. So we left with 0.50. This is divided by LQP, and this is equal to 2.0 divided by LQ times R. And for this question, we need to find out value of QP. So value of QP we have to find out. So we need to find out LQP. So we can write down in this case LQP. This will be equal to 0.50 times LQR divided by So this will be divided by 2.0. Divided by 2.0. So it simply means that what we will get LQR divided by 4, because this is 0.5 and this is 2, so we will get 4 here. So our final answer in this case is LQP, means QP, this is equal to LQR divided by 4. So the answer for this question is A. So the answer for this one is A. The quick way to answer this question is, for example, if I look at this now, this is lower than this one by 4. I mean, this is 1 by 4. So here also has to be 1 by 4. I mean, this has to be 1 by 4 of this length. So quickly you can answer with this technique if you master this kind of questions. I hope this is clear to you. If you have any questions, please leave your questions in comments. In this question, I have discussed some very important points and you need to understand those points for potentiometer. Question 38 says the table contains data for 4 different nuclei P, Q, R and S. Which 2 nuclei are isotopes of the same element? Isotopes of the same element, they must have same number of protons. Same number of protons. So here we have nucleon number and here we have number of neutrons. So the proton number, or simply we can say the number of protons. Number of protons will be equal to the nucleon number. Nucleon number is the sum of neutrons and protons minus neutron number. So we can simply say minus neutron number, because nucleon number is the sum of neutrons and protons. So from here we can find out number of protons 5, and for Q we can find out number of protons, they will be equal to 4, and for the next one we can find out number of protons, they will be equal to 8, and for the next one number of protons also equal to 8. And so it simply means that R and S, they are isotopes of same element, R and S. So the answer for this question is D. Question 39 says which statement about beta minus decay is correct? So first of all, let's try to understand a little bit about beta minus decay. So we can imagine a nucleus X, atomic number of this nucleus is Z and the mass number is A. So this decays to another nucleus Y by emitting beta minus particle, mean electron. As electron has lepton number 1, so this particle means the neutrino has to be electron anti-neutrino, because lepton number of anti-neutrino is electron anti-neutrino is -1, so in this case lepton number will be conserved. So that's the reason this has to be electron anti-neutrino to conserve lepton number. Now if you look at this nucleus, atomic number of this one will be Z plus 1, because this is -1, and mass number remains constant. So in this case proton number increases but mass number remains constant. It simply means that one neutron is converted into proton. So we can also say in this case we have quark composition of neutron. It consists of 1 up quark and it consists of 2 down quark. It decays into proton. Proton has 2 up quarks and 1 down quark. So we can also say in this case 1 down quark has been converted into up quark. Now if you look at given options, it is given to us a neutron changes to a proton in the nucleus, and an electron and an anti-neutrino are emitted. So this statement is correct. A neutron changes to a proton in the nucleus, this is right. Electron and neutrino, this is incorrect. A proton changes to a neutron, this is incorrect. A proton changes to a neutron, this is also incorrect. In this case neutron changes to proton. So the answer for this question is A. Question 40 says, what is the quark composition of a hydrogen 3 nucleus? So this is our nucleus. This nucleus, it consists of one proton. So simply we can write down it consists of one proton and it consists of two neutrons. So we can write down here it consists of two neutrons. One proton, it has two up quarks and it has one down quark. So it has two up quarks and it has one down quark. And one neutron, it consists of one up quark and two down quarks. So we need to write down the total number of up quarks and total number of down quarks. So here we have one down quark plus we have two up quarks plus we have to add this one. So we have in this case two up quarks plus we have 2 times 2 down quarks. So if we simplify this one, we will have 4 up quarks. So we have 2 up quarks here and we have 2 up quarks here, so it means 4 up quarks, and we have in this case 5 down quarks. So the answer for this question is A, means 4 up quarks and 5 down quarks. That's all for today's lesson. I hope this lesson was helpful. If this lesson was helpful, please like and subscribe because your encouragement is very important. If you have any questions, please leave your questions in comments and I will try to answer as soon as possible. And also, if you need extra help and you are looking for extra resources, join Patreon. And the link for Patreon is in the description of this video.